One of the types of sequences that you will encounter in your second year of doing A-level maths are called arithmetic sequences. Now, you might guess by the name that it's going to have something to do with addition, and that's precisely what it's going to be. It's going to be us starting with a value and adding something on every single time. So an arithmetic sequence might look something like, let's say, 1, 3, 5, 7, 9, so on and so forth. Now, in this case, we're starting with a value of 1, and each time we're adding on the value of 2. So we go from 1 plus 2 is 3, and then 3 plus 2 is 5, so on and so forth, forever or until a certain amount. And that's why it's called arithmetic, because we're adding on something each time. Now, there are two parts of an arithmetic sequence that you're going to need to identify, and that's called the common difference, which is the amount we're adding each time. So in this case, it's 2, and we typically represent that by writing d. So in this case, it's going to be d is equal to 2, because that's our kind of common difference. And the best way you can kind of typically, if it's not immediately obvious what the common difference is, because it's not going to always be as easy as this, the best way to find the common difference is just by subtracting one number from the previous number. So in this case, we can subtract 1 from 3 to get 2, or we can, for example, subtract 7 from 9 to get 2. And that's kind of the main way you can find the common difference. Now, the second part of the arithmetic sequence is your first term. So that's a term you start off when n equals 1, basically. So this is in this case, 1 is your first term. So this is your first, second, third, fourth, fifth, and so on and so forth. And so that's the other part you're going to need to identify, the first term in your sequence, which in this case is just 1. Sometimes it can be 1, it can be 2, it can be a whole bunch of numbers, but in this case we're going to do with 1. And that's going to be typically represented by writing a. So in this case, because our first number is 1, it's going to be a is equal to 1. Now, is there a generic kind of universal way we can write a arithmetic sequence for basically all values? Well, there is. So let's say we had a sequence which was, the first term was a. So I'm just going to put 1 because this is the first term. And we're going to have a common difference of d. So the second term is going to be a plus d because we're just adding on a difference. The third term is going to be a plus 2d because we're adding another d on, so another difference. And then we can also do this for, we can just write a plus 3d. Now, what do you notice about this? Well, the first thing you'll notice is that we have the first term, so that's going to be for the whole thing. And what you're noticing about the multiple of d, it's always going to be 1 less than the term it is. So if you notice, this is, for example, a plus 2d, and this is the third term. This is a plus 3d, and this is the fourth term. And so therefore, we can generally express this as being an is equal to a plus n minus 1d. And that's typically the way you're going to be encountering it when it's written. So you've got an, which is going to be, the n can be like 1, 2, or 3, so that's going to be whatever number is in your sequence, is equal to first term plus n minus 1 times the common difference. So I'll give you an example. So we're going to use the example of 1, 3, 5, 7, and 9. So if we have our sequence 1, 3, 5, 7, and 9. So in this case, our first term is going to be 1, isn't it? So we can rewrite that as an equals 1. The next part we're going to have to do is find what the common difference is, which we earlier said was 2. So that means that d is going to be equal to 2 in this case. So we're going to write this as n minus 1 times by 2. And from here, we're going to need to expand the brackets out. So it's going to then be 2n minus 2 plus 1, which we can then further simplify by writing 2n minus 1. And so that's how we're going to find the general term-to-term rule for 1, 3, 5, 7, and 9. We started by finding what the first term was, and then we did the common difference and then put it into our formula just here. Now we can use this kind of method in a variety of ways. So let's say I wanted to find the 100th term. Now we could theoretically add on 2 until we eventually get to, we can add 2 on 95 more times because it's the first 5 terms. Or there's an easier way we can do it. So the way we go about it is we write a 100 because in this case, n is whatever term it is. So what is the value when it is the 100th term? So n equals 100 is equal to 2 times 100, because that now replaces the n, minus 1. And that's just going to give us 200 minus 1, which is equal to 199. And so that's how we go about finding a particular term. So if we wanted to find the 50th term, we'd plug in n equals 50. Or if we wanted to find the 1,000th term, we'd find n equals 1,000. Another problem you might also find is something like find what is the nth term for, let's say, 51, right? So let's say we had the same examples, let's say 2n minus 1, which what we used up here. So if we wanted to find what is n at what value of n when the term rule reaches 51, in this case we're going to have to find 2n minus 1 is equal to 51, because we want to find what value of n is the sequence equal to 51. And then from here we just go about solving it. So add 1 to both sides to get 2n equals 52. And then we just simplify to get n equals 26. So what this therefore means is that at the 26th term, this sequence is going to be equal to 51. And so those are the kind of most basic kind of general ways you can go about solving these kinds of problems. There are many other ways. There are going to be worded problems, and there are going to be some quite interesting simultaneous equation problems. So be absolutely ready and be sure that you know how to do this. Thanks for watching.